Green star astronomy. In astronomy, a green star is a white or bluish star that appears greenish in some viewing conditions. See psychology below. Under typical viewing conditions, there are no greenish stars, because the color of a star is more or less given by a black-body spectrum. However, there are a few stars that appear greenish to some observers due to the viewing conditions, for example the optical illusion that a red object can make nearby objects look greenish and vice versa. Some multiple star systems, such as Antares, have a bright reddish star where this contrast makes other stars in the system look more green. Psychology of color perception. All color vision is created by the brain of the observer. As such, no star really has any color at all. Color is not out there, it is in your brain. Stars emit energy at many different wavelengths, and humans may perceive color in stars. Instead of talking about the true color of stars, we must talk about how a particular object appears to a particular observer in a particular context. This is not mere semantics. Green can be perceived when there is no green light, all for example due to the simultaneous color contrast alluded to above, in that a star can look greenish when it is next to a reddish star. Likewise, the reddish star will appear more red when next to a non-reddish star. Green percepts can also be created by blocking red light, and by adapting the red photoreceptors. See complementary colors. This is not an illusion. This is simply how humans perceive color. The perception of color in stars is complicated by the fact that the cone photoreceptors, from which color percepts are typically generated, are not active during the dim lighting conditions required to see most stars without magnification, that is, in scotopic vision. Further, stars are effectively single points of light at vast distances from the observer's eye. It is only because starlight is split, scattered, and slash, or because the observer's eye is always moving, that the light from a star can stimulate multiple photoreceptors in the retina, and therefore generate percepts of color relative to the background illumination. Why stars do not look green. A star is usually close to being a black body, give or take a few spectral lines, so its color is usually more or less the color of a black body. The color of a black body lies on the Planckian locus in the middle of the diagram shown here. As can be seen, this locus happens to pass through red, orange, yellow, white, and light blue areas, and one can indeed see many stars of these colors. On the other hand, it does not pass through green, indigo, dark blue, or violet areas, so stars that appear to have these colors are rare and depend on some additional optical effect. The blackbody colors of stars are sometimes confused with the colors of the spectrum. The spectral rainbow colors are those on the curved part of the boundary of the diagram on the right. As can be seen, the red, orange, yellow, and blue rainbow colors happen to be much the same as blackbody colors. However, stars whose peak emission is green light also emit much red and blue light, and the human visual system happens to interpret this mixture of colors as whitish rather than green. So the fact that some spectral colors appear as star colors is more a quirk of human color vision than a property of stars, if one uses an instrument such as a spectroscope that is better at distinguishing wavelengths of light, then all spectral colors look completely different from star colors. All sufficiently hot stars look about the same shade of blue and not violet as claimed in some popular accounts. The reason for this is that at sufficiently large temperatures above about 20,000 K, all blackbody spectra look about the same in visible light, though they can differ a lot at shorter wavelengths. Although their maximum output at visible wavelengths is at violet, they put out enough light at other wavelengths to look light blue, the color at the end of the Planckian locus, rather than the color at the end of the spectrum. Objects that resemble green stars. Although there are no truly green stars, There are many astronomical objects that can sometimes appear to be green stars. This section lists some of them. Multiple stars. There are a few stars in double or multiple star systems that appear greenish, even though they are blue or white under typical viewing conditions. This can happen if the star system contains a large red or orange star. Color contrast effects result in objects close to the reddish star appear slightly greenish and vice versa, complementary colors. The classical example is Antares b, the blue companion of the red supergiant Antares. Other examples include the star system Almach and Sigma Cassiopeae, a binary star 1500 light-years from Earth. Sigma Cassiopeae has a green-hued primary of magnitude 5.0 and a blue-hued secondary of magnitude 7.3. Nebulae. Some planetary nebulae glow green, especially if they contain oxygen. These nebulae, or the stars within them, usually Wolf-rayet stars, may appear to be green stars. Some examples are the planetary nebulae NGC 6572, NGC 6826, and NGC 7009. Beta Librae. The star Beta Librae's Uranus is usually reported to be white by modern observers. However, its color is controversial, and many earlier observers state that it is green. There seems to be no consensus about what its color really is, and no generally accepted explanation for why some observers see it as green. Uranus. The planet Uranus, occasionally mistaken for a star and once catalogued as 1s34 Tauri, can appear greenish as it has a lot of methane that absorbs red light. The Sun. The Sun can sometimes appear as a green spot for a second or two as it is rising or setting. Roughly speaking, the red light from the Sun is blocked by Earth, the blue light is scattered by the atmosphere, and the green light is refracted by the atmosphere to the observer. A similar effect can occasionally be seen with other astronomical objects, such as the Moon and bright planets. Furthermore, the Sun emits more green photons than any other color, i.e., it peaks in the green part of the visible spectrum. False color images. Astronomical images are sometimes printed in false colors, which can make stars look green.